we'll do a bit of revision because we've got a little bit of calculus to do. That will probably take us about half an hour, and then we're just going to start doing some exam questions, which I've set up already for us. And then that's it, really. Hopefully, once you learn it at school, everything will come back to you. You'll watch the videos, and really straightforward. I've made it really easy. So if you go to school and you realize, okay, well, this is a lot harder than I remember doing it with Sam, then there's something wrong. You probably learned it in a very hard way. So just keep that in mind as you started at school. So we are up to an application of calculus, which would be tangents and normals. So calculus has many applications, but one of the first applications is to find a tangent and normal of curves. Now, a tangent is, I'm pretty sure most of you are familiar with it. It's when it touches your curve at one point, right? That would be a tangent. Or if you remember tangents from circles, it touches your circle at one point. So these are tangents. And we have normals. Now, normals, they sound very different, but they are just perpendicular to tangents. So your normals are this. They're lines that would be perpendicular to tangents. So they're both equations of lines. Equations of lines, right? They're both lines. In other words, tangents are touching the curve once at one point only, no matter where it is. Like it could be up here, it could be here, it could be here, anywhere on this curve. And your normals are perpendicular to your tangents, passing through the same point. All right, any questions from me at this stage? All right, so before, I guess, this particular topic, you only knew this, this equation of a line. It was called the gradient intercept form. Does anyone remember what that equation was?
Is
The gradient,
y equals mx plus b?
that is correct. So from that, you had gradient, which was usually the harder one to find, and you had the y-intercept. Now, this one we don't need so much. We don't need y-intercept for what we're going to be doing here. What we will need is gradients. Now, you only had these lines for straight lines, right? So everything that we were dealing with up to like year 10 and end of year 10 has been pretty much for straight lines. So you were meant to find the equations of straight lines. Go ahead and find the gradient rise over run, and so rise over run, and then maybe you might have done another one called y2 minus y1 over x2 minus x1, you know, where you subtract your two y values over your two x values. There could have been another one where you found that the gradient is also equal to tan theta. That's all great, but that all works only because you're doing it for straight lines. Now what we want to do is find gradients of curves. And that is confusing. So imagine we had this curve, like this one here, which is just a parabola. So y equals x squared. And we want to find the gradient of that. Well, how do we do that? Right? I mean, if we had y equals 2x minus 5, well, we could straight away go, oh, yep, the gradient is 2, because that's in y equals mx plus b form. So that's easy. If we had, I don't know, if I drew you something like that, and I went, oh, that's 5 and that's 4, again, you would go, oh, yeah, that's rise over run. You could work that out. But now I'm telling you, okay, we've got y equals x squared, and I want you to find the gradient of that. Well, it's actually really easy now. Gradients of anything in the world, so even straight lines, can be found by your good friend, calculus. So by you differentiating this, it allows you to find gradients. So what is the derivative of y equals x squared? Well, the derivative, or to differentiate it, you bring the 2 down and subtract 1 from the power, so it just becomes 2x. So y dash equals to x. Now, that is not the gradient. That's what's called the gradient function. I should be very clear with that, because a lot of students keep going, oh yeah, differentiate is the gradient. It's not. It allows you, so let's write it like this, allows you to find the gradient. Cool? So if you want to find the gradient of anything in the world from now on, from pretty much today onwards, you can now know you can differentiate it, and that will allow you to find the gradient. So let me give you a basic example again. We did it up here. We went, y equals 2x minus 3. That's a straight line. I think we know what the gradient is again, just using your y equals mx plus b form. But if we, for some reason, we forgot, and we know that calculus allows us to find gradient, I differentiate this, and what do you get? What's the derivative of 2x? Isn't it just 2? Right, because the x disappears. Do you guys get that? So then the gradient is 2 in this case. Does anyone have any questions for me there? No? So far making sense? So you can see how you knew the gradient was 2, but you just used calculus, and I just proved why the gradient actually becomes 2. So I mean, in year 9, year 10, you guys just got taught, oh, it's always mx plus b. The truth of it is because of calculus. It's because when we differentiate it, it becomes 2. Now, when we've got curves, like something like this, x squared, when I differentiate it, it gives me 2x. Now, that isn't the gradient because it's still got an x, right? But it allows me to find the gradient. Now, when you do y dash equals to 2x, that's everywhere. That's anywhere on this curve. So what you want to do, if you want to find it specifically, like let's say at that point, well, what would you do if you want it to be specific? If you want the actual gradient at that point, what do you guys think? If you've got y dash is 2x, and you want it specifically at a point here, let's call that point 2, 3. What would you do to find the gradient at this point instead of at this point, let's say? Anyone have any ideas? Y dash equals 2x, and I want it specifically at this point. No?
Would you sub your points?
Yeah. See, and the reason why I say that, look, the reason why I like you guys, I mean, let's say getting it wrong even, it's because that it probably won't be wrong. It's better to try it. Not trying it is a problem. When you get into exams, you're going to get stuck with something somewhere, something that might be a bit more, let's say, I don't know, new or worded differently or whatever it is. You'll get stuck, and because you haven't taught yourself to try, you're not going to try in the exam either. You're just going to be like, oh, I can't do this because I've never seen it before. But if you try and actually get things right or wrong, you wouldn't know. You'll be very surprised. Most of the time, your guesses will be right. Yes, if I've got y dash equals 2x, like I said, it's very generic. It's a gradient function, allows you to find the gradient. So 2x means it's 2x anywhere, depending on your x value. So if you want it specifically there, your gradient of your tangent is just 2 times x. And that's it. It's that simple. All right, so let's just do a quick recap. We want to find equations of tangents and normals. So we want to find equations of lines. To find equations of lines, we need gradients. That's probably going to be the biggest thing you want to know. The points and stuff will usually be given to you. So the hardest bit is the gradients. So to find the gradient, we now know we have to differentiate it. So we got to do y dash. How do we do y dash? You follow your rules that you learned last week. So you just bring the power down and then subtract 1 from the power. This is not the gradient if it's got an x. See the top one up here, when I differentiated it, it actually just gave me 2. Well, that is the gradient, because it doesn't matter where the x is, it's always 2. In this case, it gave me an x, so that's not really the gradient. that allows you to find the gradient. So what you've got to do is just sub in, your x value wherever it is. If I told you I want -1 and I don't know 4, that one there, you'll just sub in -1, and that will give you this gradient. And 2 times -1 is -2, and you can see that slope to the left. So it all works. And then once you find your gradient, we should be able to find out equations of lines. And I'm going to tell you how to do that shortly. All right. Anyone have any questions for me before I pretty much start this up? No. All right, let's have a look at the question. Pretty much example 12. Find the gradient of the function at the point 2 and 6. Okay, what's step 1 to find the gradient? Step 1, differentiate. So y dash equals, differentiate x cubed, bring the 2 down, plus 6. The 2 disappears. And just again observe, the cubic became a quadratic, power of 2. The quadratic became a power of 1. The power of 1 became a constant. The constant disappears. Okay, does anyone have any questions for me for that? Anyone need a recap of differentiating? Okay. Angelina, just quickly, did you get to watch the calculus video, or you haven't watched that yet?
I've watched the first part, but I've got a bit of a grasp on it.
Good, great, thank you. All right, so y dash 3x squared minus 6x plus 6. All right. And then, again, that is my gradient function. It allows me to find the gradient. It isn't the gradient. To find the gradient, it's telling you it's specifically at the point 2 and 6. So we write m, instead of y dash. I like to write the letter m because obviously, m stands for gradient. That's what you're used to. The first one you usually find is tangents, and I'll show you how to find normals soon. So I like to write mt, just so you guys can get used to that's your gradient for your tangent. All right, just sub in 2, and you're done. Easy stuff, right, you guys? What's that? 12. 12 take away 12 is 0. The answer is 6. Easy marks, no problems. I know in the Thursday class, I was doing we went through a prelim exam with them just to show it, because right after this topic we've got logs and exponentials left, and then probability, and we're done. So with them, we've already done logs and exponentials. We're up to probability. So I decided before we start that we went through a whole prelim, and that was the question. And that's it. You just got to know a little bit of everything. You don't need your 1,000 textbook questions. You just got to know the topic, know how to explain it, and you're good to go. Okay. All right. Now, how do I find normals? So the way you've got to find your normals, again, we're going to look into the equation in a sec. But to find the gradient of my normal, you must first find your gradient of your tangent. So you found your gradient of your tangent, which is 6, let's say. And if you ask me to find the gradient of the normal, you'll actually say, like say here, equation of tangent compared to normal. So you'll know which one you've got to do. You first have to find your tangent, which is 6. Does anyone remember the idea of if a line is perpendicular to another line, what we know about their gradients?
They multiply to make -1.
That's it. If m1 times m2 is equal to, if m1 is perpendicular to m2, so if two things are perpendicular, then m1 times m2 is equal to -1, or in other words, I like to just say that one of the gradients is the negative reciprocal of the other one. So that means if mt is equal to 6, mn, your gradient of your normal is the negative reciprocal of 6, which is -1/6. Anyone have any questions for me? No, that all makes sense so far. We could just jump straight into more questions. All right, last thing you need to learn for this, and then you're pretty much finished with all of this, is how to actually find the equation of a line. Now, does anyone remember how to actually find an equation of a line? So to find the equation of tangents and normals, you need to know the equation of a line. It was, I think it's called point gradient formula. Maybe some of you might remember it like that. Does anyone remember that? Find the equation.
Is it like the formula that's like y minus y1?
Yes.
But I don't remember the other part of it.
You said it. Y minus y1 equals m bracket and then change the letters. What do you think?
Isn't it like x minus x squared or something?
Come on, you said 1 here. 1.
Oh, x2. Yep.
No, x1. x1, exactly the same. So y minus y1 equals m bracket x minus x1. Perfect. Now, this formula, I can tell you, will be worth at least 10 marks in your HSC. That's how many times you're going to use this formula in your HSC. So probably one of the most important equations or formulas you need to remember. That is to find the equation of any line. Oops. Okay, you cannot forget that. So as soon as you see the word that says find the equation of, or find the equation of a line, or tangent, or normal, it's always this formula here. You cannot forget this formula. Super important. Okay, let's get started. So, with that formula, all we'll need is obviously a point. There it is, x1, y1, and a gradient. The point's usually going to be given to you. It's the gradient that's hard. How do we find the gradient? Obviously, we just did it all above here, y dash, and then you sub it in. So let's have a look at this question. If f of x equals x cubed, take away 3x, find the equation of the tangent at this point. Okay. F dash. All right, well, maybe I should do this one with someone. Shania, let's start with you first, if you don't mind. Let's differentiate this.
Okay.
So, differentiate x cubed.
So it'll be 3x squared minus 3.
Beautiful. So that is called the gradient function. That's not the gradient. To find the gradient of your tangent, what do?
You sub in.
So, simple. Sub it in. 4 times 3 is 12. 12 take away 3 is 9. We don't need it for this question, but just so I know that you understand this, do you know what the gradient of your normal is?
Minus 1/9.
Great work. But we don't need it for this question, so leave that out.
Okay.
And then equation of a line. Y minus y1. Now, what's your y1 value? 2.
Okay, cool.
Equals 9. X minus, what's your x1 value?
2.
So x1 and y1 are just going to be your points. X1,
Alright, cool.
y1. And then obviously in the HSC, again, just so you guys understand how HSCs work compared to your school teachers, that's 4 marks. Right? Because that's the equation of a line. That's the formula. Now, but what you've learned, obviously in year 9 and year 10, that you can have it written in 2 forms. These are forms, not formulas. So forms means it's just what they are written as. So y equals mx plus b, you could write it like that, or in general form. You can write it in either one. It doesn't really matter, unless the question specifically says obviously write it in general form. So I'm just going to expand, but just so you guys are aware, that is 4 marks with the first line. You don't need to expand. But there it is. It's simple to expand anyways. Sounds good?
Yep.
Good job. Easy. Anyone have any questions? Okay. If f of x equals x plus 1 on x, find for what values of x the tangent is horizontal. Okay, this one doesn't say to actually find the equation of the tangent. I'll come back to this once we're a little bit stronger. Wait, I want to do a few more questions of just tangents and normals. And look, there it is, HSC questions. These are actually trial HSC questions, just compiled into topics, and we're just going to pick one. There it is. That came from the 2-unit 1985. It's a long time ago, but it doesn't change. Look how long it's been. has never changed. Math cannot change. So again, as always, you don't need 1,000 questions. Just be really strong with a few. Understand the concepts. Try to teach it to your siblings, to your parents. If you're able to do that, then you pretty much know the topic. Find the equation of the tangent. Anouk, let's do this one. At the point 1 and 12 on the parabola, y equals x squared equals plus 6x plus 5. All right, what's your first step?
You differentiate it, so it's going to be 2x plus 6.
You got to say y dash.
Yeah.
Equals 2x plus 6. Then
you sub in 1. X equals 1.
Gradient of your tangent. Yep. X is 1.
Yeah. Now you use your point gradient formula and the points and the gradient. Yeah.
So tell me, y minus?
y1 equals mx minus x1 in brackets.
Yep. So what am I going to write?
Y minus 12 equals 8 bracket x minus 1.
Easy. And then if you wanted to expand, that becomes 8x. Take away 8 plus the 12. We're done.
Yeah.
Any questions? All right, let's do another one. I'm just going to keep doing some exam questions until you guys go, I'm confused now. All right, wait, let's do a normal so we can start doing some normal questions as well. Normals. All right, here we go. Find the equation of the normal. Okay, simple. The equation of a normal. Well, a normal is still a line, so that's still the equation of a line. So we're going to use the same formula, right? It's still this. To the curve y equals 4 minus x squared at the point P, 1 and 3. So we already know what x1 and y1 are. We just don't know what m is. But we've got to remember we're doing it for normal, and we know normals are negative reciprocals of tangents. So to be able to find normals, you're going to firstly find your gradient of your tangent. All right, Queenie, let's do this. Y dash equals?
Y dash equals negative 2x.
Beautiful. So gradient of your tangent equals?
Negative 2.
Yep. Gradient of your normal equals?
1 on 2.
Yes, perfect. Negative reciprocal of negative 2 is 1 on 2. And then obviously, and please, be very strict with yourself by writing these y dash, mt, mn. I mean, the last thing you want is to confuse yourself when you're writing all this. If I ignored, I've seen it, I've seen students ignore all this and just do everything in their head. But like, you're going to get yourself confused. You're going to get the markers confused. We don't know what you're doing, and you probably won't be getting full marks if you don't write it properly. Cool. And then y minus, what are you going to say?
Y minus 3 equals half x minus 1.
Beautiful. And then what would you usually do if, I mean, again, that's full marks because it just says find the equation. You guys got to understand that. It doesn't say show what the equation is. It just says find it and you found it. But if you wanted to move forward, what would you do, Queenie?
Bring the half to the other side.
You would bring this half to the other side? I think you got the right idea. I don't think you said it right. Let me make it clear. You don't. I probably would not expand the half. Okay. Especially being extension students, I don't think you guys should be expanding the half because then you're going to deal with fractions and that just makes it a lot harder. It's probably better to multiply by 2 onto this side. I think that's what you're trying to say, Queenie. So times it by 2 onto this side. So 2y take away 6 equals 1 times x, which is x, 1 times net, and look at that. No fractions, looks beautiful. In this case, I would probably write it in general form, which means you've got to keep x positive, bring these guys over. Minus 1 plus 6, and you're done. Any questions, anybody? We understand how to find our normals. All right. Let's have a look at some exam questions again. Find the equation of a normal. These are actually asked. 2 unit, 1986, question 2 II. These are proper exam questions, right? I'm not messing around with you. There you go. Let's go. Find the equation of a normal. Whose turn? It is Novak. Novak, is your mic working or still?
Yeah, I was just eating, my bad.
Ah,
before.
all good. I thought so. I thought maybe you're eating or you just got up and you don't want to talk.
Yeah.
Find the equation of a normal. Y dash equals
3x squared minus 1.
2. Good. MT equals. You have to always find your tangent before you can find your normal. Yep.
Sub in 2, so that would be 17. Yeah.
17. 4 times 2. 2 squared is
11, my bad.
11. Yeah.
Yep.
Careful. 11 and then MN.
That would be a negative reciprocal, so negative 1 over 11.
Y minus
Y1, so 11
equals
equals minus 1 over 11, x minus 2.
times Y.
Times y with 11. 11y minus 121 equals minus x plus 2.
And then you usually want to keep X positive, so bring X over this time. And you would be done. But like, again, full marks, full marks, full marks. If it's a fine question. Done. You guys are getting better and better at it now? Let's have a look at another one. Okay. I mean, that's a good question. Determine and don't overthink it. Determine if the line 7x take away y take away 3 because there is a tangent to this parabola. All right. Is a tangent to the parabola. Let me see how we're going to do that. Okay, here we go. So, anyone have any ideas of how to determine if this line is going to be a tangent to this line, or to this parabola, sorry.
Do you put it in y equals mx plus b form and
And
find the
why did
gradient?
you think that? Yes, absolutely right. So, yep. So Queenie just said put it in y equals mx plus b form, and the reason why she thought of that because she's like, oh well, if I have it in that form, I would already know the gradient of this line, which is 7, right? And I pretty much know the y-intercept of this line even, which equals to, I don't know, -3. It's just, I don't know if you need that, but just for your own curiosity. But more, we need the m equals 7. Then to determine if this is a tangent to this parabola, well, we also know that the derivative of this must get me the gradient of 7 as well, which happens to be y dash equals 4x plus 3. Right? Now we know if this was to equal to this, what must x equal to? If this must equal to this, what must x equal to?
1.
Yep. Just x would have to equal to 1. If x equals to 1, the y value needs to be the same in both. Are you guys understanding what's happening? So pretty much this is what's happened so far. You've got a parabola. Let's just say it's been like that. You found that the gradient's the same. That's great. I mean, gradient could be the same here. There. This is all parallel. These would all have gradient of 7. Right? You found that it occurs at 1. Again, that's great because it could be here, it could be here, it could be here. Anywhere, all of these have x equals to 1. Right? See, they all have the different y values. They have the same gradient, same x value, but different y values. But what I'll do to finalize it is I'll sub this x value into here, sub the x value into here. Fingers crossed, if it gives me the same y value, then you would say, yes, it is true. This is the tangent to this. If it's not, you would say, no, it's not. So here we go. Check. 7. Well, might as well just sub it into here, right? y equals 7 take away 3, which equals to 4. Into here, y equals 2 plus 3 minus 1, 5 take away 1. Yes, the line is tangential to the parabola, or is a tangent to the parabola, however you say that. Very, very clever, Queenie. Good job. With that right there. That was probably the most important bit. And I mean, Emily and Anouk, we were talking about this just before. I was saying, like, you guys guessed what to do. I hope that most of you would have guessed that if the question says tangent from now on, you think of differentiating it anyways. So you've got to put that in, and then hopefully you start to think about, okay, now I know the tangent. I mean, I know the gradient function, but I don't know what the gradient is. But oh, I've got this line, and I can work out the gradient of a line. And then maybe you would have linked it together, and then, you know, this bit here is where students usually forget to sub it back in to check if the y value is also true for both. But that's it. Let's have a look at another one. Am I going too fast for anybody? Yeah, let's do that one. Okay. Before I can start this one, I've just got to clear up one thing one more time. So, gradient can be written as rise over run, which, you know, very poor. Can be written as y2 minus y1 over x2 minus x1. It can be written as tan theta and now y dash. Now, has anyone not seen that m equals to tan theta is a result? Because it's very, very rare. I mean, in textbooks, and it's very rare in exam questions, so it's usually only one little component. Has anyone actually not seen? Yeah?
I've never seen that.
All right, I'll prove it for you.
As well.
Yeah, let me show you something then. So we have this. I'll prove it, but pretty much from today onwards, you have to remember that for gradient, there is pretty much that, and there's even this one, of course. You know, y equals mx plus b. So if it's a line, you can get the gradient from the line. So if you've got a line, you can get the gradient from the line. You can differentiate it. You can get it from angles. You can get it from 2 points, and you can get it from rise over run, which is probably year 8. But there's a lot of ways to get gradients. You got to keep that in mind. Now, this tan theta one, if you ever see angles with gradients, it's always talking about tan theta. I'll prove it real quick. There's your theta. Tan theta is opposite over adjacent. If I change opposite and use the word rise, and I change adjacent and use the word run, you would obviously get tan theta equals rise over run, which means tan theta is equal to m. So the gradient is equal to tan theta. So that's the most basic way to prove it. But pretty much from now on, you need to know if you ever get gradient and you've got an angle, it's always talking about m equals tan theta. A quick point there, actually, it's an acute angle. So it's an theta equals acute angle in that direction. Okay, so if I wanted to find the obtuse angle, this bit here, you have to subtract from 180. I think, which you guys would understand that. So if you ever said to find the obtuse, it's 180 minus theta. So be careful. Theta is acute. All right. So, knowing that bit of information, we shall start with this question. It's a two-part question. It says, first, that's the y value. Show that dy and dx becomes this, so differentiate, and it should become this. And then hence find the equation of the tangent to that curve at this point. Oh, it's 3 parts. And then find the acute angle that this makes with the x-axis. So I can tell you 2 marks for that one, 2 marks for this one, 1 mark for this. This question right here is a 5 mark question. So 5 marks in your exams. Who's going to try it? Whose turn is it? It is nada. Unlucky. You probably got one of the hardest ones. Tell me, are you ready for it?
No.
Oh, come on, we can do it. Don't worry. Let's do the first bit. So we've got y equals x squared on x plus 1. All right, we have to differentiate this. Do you remember what you must use if you've got two x's like this?
Yeah. The UV thing.
Do you remember the word by any chance? Started with Q?
Product.
Started with Q.
Oh, yeah. Quotient.
Yeah, product would be the word multiplied, right? Quotient means divided. So quotient rule, good job. And then, do you remember by any chance?
Y dash V minus V dash U over V squared.
Yeah. So U dash V minus V dash U over V squared. U and V. So Y dash or dy on dx is the same thing, right? U dash. So what's the derivative of x squared?
2x.
Times V
X plus 1.
minus V dash, the derivative of the bottom,
Just 1.
times.
X squared.
Beautiful. So I just ignore the 1 eventually. Over.
X plus 1 squared.
And like I said, the idea with these, like calculus, don't expand the denominator. So just leave it as it is. And you're hoping the top becomes this. So let's have a look. 2x squared plus 2x. And can you see you've got it? 2x squared. Okay.
Yeah, but you're kind of glitching. Yeah.
Okay. Am I glitching for anyone else, or was it just another
Yeah, it was for me too.
happening for you as well? Okay. That's strange. Has it happened from the beginning of the lesson?
No, just started.
Just now? Okay. Let me know if it happens again. I might have to restart the call. We'll see how we go. Okay. Hence, find the equation of the tangent. Whose turn for this bit then? We'll split it up. Andy, let's try to find the equation of the tangent to the curve now. So you've done part 1, which was 2 marks. Now we want to find the equation of the tangent, which would be subbing it in. So you've already differentiated.
Yeah.
What's your gradient of your tangent? What are you going to do?
Squared
Yep.
plus 2 is 1 plus 1 squared.
Yeah. So that's 3 over
4.
4. Good. And then pretty much finish it off. Y minus y1, which is
A half.
equals
3 on 4. X minus 1.
and then you might as well just make it look a little bit better. What are you going to do?
Times 4 over and times 2 over.
Oh, when you times, you would usually, but I guess look, when you're going to times this by 4, it's already going to become 2.
Ah, yeah.
You just leave it.
Okay.
Don't even bother multiplying everything by 2 and 4. 3x, take away 3, and then bring everything to one side. Keep x positive.
Yep.
Minus 3 plus 2 is minus 1. Okay. Good job. Any questions? Last one. Emily, let's find the acute angle that this tangent makes with the x-axis. So we know to find the acute angle, we've got to use tan theta equals to m. What does
the rise over run, which is like O over A, opposite over adjacent?
Yeah, but hold on. No, I was proving that. Wait, don't let that confuse you. I was trying to prove it. All you need to know is tan theta is equal to pretty much m.
Yeah.
That's the only thing you want to remember. So tan theta is equal to m. What does your gradient equal to in this case?
The gradient is 3 over 4.
Yeah, and then obviously you just want to find the angle theta. So what are you going to get rid of? Tan. And how do I get rid of tan? Pretty much you're solving for theta. How are you solving for theta just in our last topic?
Oh, you just put like tan negative 3 over 4 in the calculator, which is just
Inverse.
36. Yeah.
Yep. And then 36 point what? Nearest degree.
0.87 degrees.
So then it should be 37 degrees.
Yep.
That's how easy that one is. That's just a matter of you remembering tan theta is equal to m. And let's double check it all. 37. I think we've got it all. Well done. Anyone have any questions for us? So recap, 2 marks there for quotient rule, 2 marks there for working out your gradient first and then to find the equation of your line, and then 1 mark for just shifting tan inverse of 3 over 4. Good work. And that's how you get rid of tan. You just do the inverse of it. Or you can say shift tan, I don't really mind. All right, I guess I'll try to find one a little bit harder. Find the coordinates of the point where the tangent is parallel to the straight line of this. Yeah, that looks good. Yep, that's a good one. That will get you guys. I'm going to try doing some of these harder ones now. Find the coordinates of P. Harder only because it's a bit applied. Not that it's any harder. You can't do that one. Let's try to find another one before we do. Show the equation of the normal is given by this. Yeah, that's simple. All right, good. Right, let's get back to this one. Finish off this booklet. And then we'll come back and we'll do some more exam questions. Okay, so this question here, it says f of x equals x plus 1 on x. Find for what values of x the tangent is horizontal. Okay, what do we know about something if the tangent is horizontal? The tangent is horizontal. What does that tell us about the gradient? Well, if something's horizontal, it has no gradient, so the gradient is 0, right? It's not sloped up or anything. It's just 0. So if it says the tangent is horizontal, you know that the gradient of your tangent is just going to equal to 0. So we differentiate, as you know you must do. So this can be written like this. Right, cannot have x in the bottom. Derivative of x is 1. Derivative of x take away 1 is negative x take away 2. Subtract 1 from the power. There it is. We know that the gradient of this is equal to 0. And you're trying to find x. So pretty much just solve for x now. Basic stuff. Times them both by -1, multiply x squared over, therefore x equals to plus minus 1. Be careful when you square root that, you've got to write plus minus 1. A trick there that a lot of students are not, are not taught, if it does say values, plural, it usually is there for a reason, and it means plus minus, or it means two solutions, or at least two solutions. So just keep that in mind. That's an exam style question. If you ever do say find what values of x, you already know that there's going to be at least two. Okay. Anybody confused about what I just did there? Or do we understand the tangent is horizontal, therefore mt is equal to 0. Your gradient of your tangent is 0. All right. Let's try another one then. Find to 4 sig figs the x-coordinate of the point where the tangent of this function has an angle of inclination of 22 degrees. All right, Anouk, let's try this one. What do you know from this so far?
Would you have to use the tan theta thing?
Yes, because that's the only part you have angle. It's the only thing you ever have angle with like gradients or tangents or anything else. Other than tree, if you ever see an angle, it's always going to be this formula. There's nowhere else would you use angles other than tan theta is equal to m. So
yeah,
you know the angle of inclination is 22 degrees. So pretty much you know the gradient straight away. Do you agree with that?
Yeah.
So the gradient looks like it's 0.404. And then it says find the x-coordinate of the point where the tangent has an angle of inclination. Okay, what are you going to do?
Would you differentiate? So it's going to be 2x plus 3.
Yes, and then?
Would you sub in something?
Okay, look what you're trying to find. I'm going to try and make it really easy for you. Don't lose track of what you're trying to find. What are you trying to find here?
The x-coordinate.
Now, if you're going to say, hey, sub something in, if I sub it into x, did you just find x or did you just get rid of x?
Oh, we got rid of it, right?
Yeah, so you probably don't want to take that approach. Okay. If it says find x, you definitely want this x here. So you've got to think of it in a different way. You've got to go, okay, I know y dash is this, and I know my gradient is this. How does these two link together?
Would you set it equal to 0.
Yeah.
Yeah.
And why? Why does that make sense?
Because you know your gradient must be 0.404.
Yeah, and y dash is the gradient, isn't it? Y dash allows you to find the gradient, but you already know the gradient. You just want to find out where that point is. Good job. And then, of course, x equals, because it says, I know 4 sig figs, so I just wrote it to one more number. X equals, subtract 3, divide by 2. Take away 3, divide by 2. Negative 1.298. 1, 2, 3, 4. 4 sig figs just means the first 4 non-zero numbers. So 1, 2, 3, 4. 1, 2, 3, 4.
Yeah.
Can't start with the 0. And easy, right? No?
Yeah.
Look, again, let's just recap. You said sub it in, but it says find x. Sub in usually not right to find x because you're trying to find x. You don't want to get rid of it. So you would want to get rid of y dash. You can say, hey, sub in something for y dash. And yes, what does y dash equal to? Y dash is equal to the gradient, which is 0.40. Subbed it in, and then you solved for, of course, x.
Yeah.
Good work. All right, now another one. Oh, that's it. All right. Okay. Last bit of calculus, pretty much. Just to tell you when things are, you're allowed to differentiate them and when you're not. So a function is differentiable if the gradient of the tangent can be found. So pretty much you can only differentiate if you can actually find the tangent. Some graphs are differentiable in places and not differentiable in others. So consider the following. So you see, you can find the gradient of all this. We can find the tangents, tangent, tangent, tangent. But eventually, once you get to here, there's a break. So you can't actually differentiate this. Again, you can differentiate, 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 and then here, well, it's open circle, so you can't differentiate that. It's not including that section. And then anything that is a corner, so absolute values, for example, you can't differentiate because they're sharp. And what happens is they get you straight lines, right? The tangents are straight vertical lines. And does anyone remember what the gradient of a vertical line is? So gradient of horizontal lines was 0. That was 0. These are positively gradient or positive gradients. These are negative gradients. What about straight lines? Vertical straight lines.
Undefined.
Yeah, undefined. Do you remember the reason why they're undefined? This is just a slope, right? You've got no slope, 0 slope. You're flat ground. You've got positive slope. You've got negative slope. This cannot be a slope, because if something is a straight line, like let's just say a wall, you cannot climb that wall. There is no slope to be able to climb that wall. All right, you cannot climb that wall, or you can climb. I mean, you can't walk on that wall vertically. Anyways. So these are undefined. All right. In general, a function is not differentiable where there are gaps or sharp corners. In other words, for a function to be differentiable, it must be continuous at that point. In the graphs below at points A and C, the gradient function does not exist since the function has gaps and sharp corners. So see there, you can't find the gradient there. You can't differentiate that. You can't differentiate that. You can differentiate everywhere else. They're not a problem, but you can't differentiate it there and there. To determine whether a function is differentiable at any particular point, this is A as in A here, and then you've subbed it in to get f of A. You check whether the function is continuous at x equals A. Continuous means that when I sub it in, there is no gaps, there's no pauses, there's nothing like that. And then you would test whether the limit as it's approaching from the left-hand side, so negative, is the same as it's approaching from the right-hand side. Excuse me. So let's have a look at this. Is the function f of x equals differentiable for all values of x? Well, step 1, check whether it's firstly continuous. For it to be continuous, that means at 1, this must give me 1. And what happens when you do sub in 1? Well, 1 squared is 1. And when I sub in 1 into here, 3 times 1 is 3. 3 take away 2 is also 1. So far, this function is continuous. Right? Second thing is, I've got to test whether the limit at 1 for f dash of x for this one is the same as f dash of x for this one here. So f dash of x is 2x, and this one's 3. When I sub in 1, you get 2. This is still 3. You can tell that the gradients are not the same. So, is this differentiable for all values of x? No. It is not differentiable for all values of x. Does that make sense to you guys? Let's try it again. Is the function f of x differentiable for all values of x? All right, we'll test step 1. Step 1 is to sub in 1, and there must be no jump. So sub in 1, 2, take away 1 is 2. Sub in 1. 1 take away 2 is negative 1. Squared is 1. That's already no. Because when you're going to draw this, it's going to have a y value of 2 at 1. When you're going to draw this, it's going to have a y value of 1 at 1. So there's going to be a bit of a jump there. Do you guys understand that?
Sam, isn't the first one 1 as well? Because 2 take away 1 is 1.
Oh, crap. I don't know what I did there. How did I get 2? 2 take away 0. Oh, that was bad. 2 take away 1. Let's rub that out. 2 take away 1 is 1. Okay, 1 take away 2 is negative 1. Negative 1 squared is 1. All right, so step 2. Step 2, differentiate. Equals. Derivative of this is negative 2x. Derivative of this is 2 bracket x minus 2 to the power of 1. Okay, then you sub in 1 into here. That gives me negative 2. Sub in 1 into here. 1 take away 2 is negative 1. Negative 1 times 2 is negative 2. That actually is a yes. Thanks, Anu, for saying that. That just changed the answer altogether. So it is continuous and it's differentiable. So is this function going to be differentiable for all the values of x? Yes, it is. All right. Let's smash out exam questions. I'll save that. I'll send that to you guys into your group chat. That is done. The book is finished. All right. All right, I feel like we're okay with that. Don't worry about these e's and tans. That's only once we've done differentiation of exponentials and differentiation of trig, which is going to be coming up soon. Not yet. So that's in maybe next term. All right, let's have a look at some of these harder. Let's start from the top again. Look for some harder ones. We just did that. Find the equation. Find the coordinates of the points where the tangent is parallel. That one. Okay. Find the coordinates of the points. So now we're actually trying to find the points, x and y. On the curve, y equals 3x squared, take away 2x plus 1, where the tangent is parallel to this straight line. Okay, who wants to try this? Find the coordinates on the point of the curve, where the tangent is parallel to this straight line. No, Shania, then we're going to start from the bottom. Shania, you're going to go for it. Find the coordinates of the point on the curve y equals 3x squared, where the tangent is parallel. All right, what are you thinking? Don't overthink. All right, that's step 1. Step 2, do what we've been doing, I guess. What are you going to say?
I'm guessing differentiate.
Yeah, which one? The first one or the second one?
The
or
first.
both?
Both, basically.
Say that again?
Both.
Yeah, both is fine. You can actually differentiate both. So let's do the first one. So the derivative of this is what?
6x.
Take away?
2.
And therefore your gradient so far of this is 6. Sorry, no, whoa. Forget that. What I just wrote there, that was bad. I was thinking of this one. This one here, the way Queenie had done it before, she just made it into y equals mx plus b form. So if you bring the y over, you do get this, and you should be able to see the gradient. But we're going to differentiate it anyways, because it has to be y equal before you can differentiate. So what's the derivative of 4x?
4.
4. So I mean, there's two ways. You can either put in mx plus b and just see the gradient, or like you said, differentiate both. There it is. And then what are you going to do? If you know that they are parallel to each other, what does that mean about their y dashes, their gradients?
They're the same.
So what are you going to write? They're the same. Come on.
So 6x minus 2 equals 4.
Yeah, exactly. Plus 2. So that becomes x equals 1. You wanted a point. What are you going to do?
So we need to find y, sub it in, I guess.
Sub it in. You are right. See? That's what I mean by don't overthink it. When you guys start to overthink your questions, it all goes bad. You're done. 1, 2. Finished. What did you do? You just differentiated everything you know, and instead of finding gradients, which you were given points, this time we didn't give you the point, but I gave you the gradients of each, and then you just equate and solve for x, and then eventually to find y, you just sub it in. Perfect. Great work. Let's do another one. All right. Novak, I guess you can do this one. So a little bit harder, but never impossible. So I'll let you read it for 2 seconds and tell me what you know, what you understand, what you don't understand. Tangent to the curve intersects the x-axis at P and the y-axis at Q, and angle OPQ equals OQP. Explain why the gradient of PQ is -1. Okay. So Novak?
Yeah.
Sounds weird.
Yeah.
Okay, but you can't just skip information. So you got to start from the top. A tangent to the curve y equals 4 on x squared. We get that. Intersects x-axis at P. What do you know? What does that mean? What do you know when it intersects the x-axis, firstly?
Simultaneous?
Yeah, sometimes. Yes, I'll agree with that. What do you specifically know about... well, okay, do you know what the x value is there?
0.
No.
The
you
y
know what
value.
the y
0.
value is. That's what I was trying to get. So you don't know what the x value is, but what do you know about the y value?
It's 0.
And what do you know about when it cuts the y-axis?
X is 0.
Okay, so you specifically know that. Okay, that's 2 pieces of information that you know, which is great. And what? And it says OPQ is equal to OQP. So what is that trying to say?
It's the same angles.
Yep, and then if these two are the same, do you know exactly what their angles must be?
Yeah.
What?
45.
Yeah, exactly right. So this angle in here is 45 degrees, and this angle in here is 45 degrees. Because that's a right angle there. So
Yeah.
that means if these are 45 and 45, well, what do you know from that? You know this bit is equal to this bit.
Yeah.
You see? And the question says now, explain why the gradient of PQ is -1. And you're like, well, I know OQ is the same as OP.
Yeah.
So to find my gradient, I would say this is called rise. Sorry, OQ over run, but OP is the same. So it's still OQ, isn't it? OQ over OQ, which equals to 1. But I know it's sloped to the left.
Oh, so it's a negative.
That's all. You guys are going to look at that and go, I don't get it, but because you keep missing this important information here. And you know, when you're doing your work, you jump straight into I, and you're not teaching yourself to actually pause there and put everything in and tell yourself, okay, what do I know about all that? 45, I know it's an isosceles. I understand this equals to this. Okay, now let me try. Gradient, oh yeah, maybe rise over run, because that's the way you probably approach that. And there it is, simple stuff. And if you didn't, at least now that you've seen it a second time, maybe in your exams or whatever it is, you guys remember this and easy. Double A, Novak. Show PQ is tangent to the curve at 2, 1. So it's saying, show that there's a tangent here at 2 and 1. So you got to find that though. It doesn't say find the tangent. That's triple A. This one just says, show that there's a tangent that exists here and it's at 2 and 1. All right, what are you going to do? What do you think?
You gotta show that there's a tangent at the curve 2, 2, 1.
So what's going to be your method for this word right here?
Differentiate?
Yes, correct. So once you see that, you're already starting to think, okay, I know that that means differentiate. Tangential means great. I know to differentiate this. Okay, so you've got y equals 4 on x squared. Don't forget the topic. The whole topic is calculus.
Yeah.
So if you don't differentiate, something's wrong. Y dash equals. All right. Tell me.
Minus a x to the power of minus 3.
Okay, and what do you know about that gradient? Well, you know that is the gradient function that works everywhere, right? Everywhere, everywhere, everywhere. But you know specifically there, the gradient is -1.
Yeah.
So what are you going to write now? -8 on x cubed, I hope, equals?
-1.
Then multiply.
-8 equals minus x cubed. X cubed equals 8 and x equals √8. So 2. Yeah.
So that's good. You got the x value, but you haven't shown the y value. 4
Sub it
on
back in.
x squared. Yeah, sub it back in. Easy stuff. Therefore, 2, 1. Find the equation of the tangent. Go ahead. Y minus,
y1
which is,
1
equals,
equals, where was -1?
yep, bracket,
X minus 2.
and then I'll finish it off.
Yeah.
That becomes +2. +2 plus 1 more. And you're done. All right. Anyone, any questions? Let's go again. Let's find another hard one. Maybe this one. Just so I got to go back because I saw y-axis. See, Nova, you didn't even need the x-axis at P and the y-axis at Q so much, but it's important for you to get used to knowing that means x is 0 and that is y is 0. But we didn't need it in this question. Doesn't mean you won't ever need it.
Yeah.
All good. All right. Next, let's try. Whose turn? Yeah, Emily, why not? Let's go again. Diagram shows the parabola y equals x squared, take away 3x, and the tangent drawn. Diagram shows. Oh, okay. Hold on. There it is. Need all that. Okay, let's have a read. Diagram shows the parabola y equals x squared, take away 3x. Yep. And a tangent drawn at P. There's a tangent drawn at P. This tangent has gradient 5. Okay. And it cuts the y-axis at Q. Interesting. And then it just says find the coordinates of P. And so what to do, how to do it. It just says find the coordinates. Then eventually we're going to find the equation of the tangent. And then eventually find the coordinates of Q. All right. So, Emily, what do you know? This tangent has gradient 5 and cuts the y-axis at Q. Yeah, go ahead. Up to you.
Would you like to differentiate first, like y equals, so it would be y equals to 2x minus 3.
Y dash.
Dash, sorry.
Yeah, 2x minus 3. Yes.
The tangent is a gradient of 5, so would you sub that into the equation?
No, you're not going to sub it in. The gradient is 5. So you're going to make this
Equal to 5?
Yeah.
Okay.
And then think about it. If I did this, just I want to show you something. If I subbed it into 5 here, even though it's super wrong, because that's an x value, it's a gradient of 5. But just look what you're going to get. You're going to get 10 take away 3, which is 7. You just found the gradient now is 7. But the question said the gradient is 5.
Yeah.
And you're going to so confuse yourself and be like, what am I doing? So yeah, just be careful with that. It's not an x value, it is gradient, which is usually y dash, so that equals to 5. And then what letter would you be solving for?
X, so it will just equal to 4.
Correct, and that usually would make sense for a coordinate. You found x is 4, and then you need to find the y value.
For y value, you just get rid of, so wouldn't it just be, sorry, I'm just thinking.
Oh, you're very close. X equals 4. You want to find y. What does y equal to? Somewhere here.
Is it just y equals to, sorry, I just stopped thinking.
Wait. What does y equal to here? It's all good. I got you. Y equals what? X squared. Take away
minus
3.
3x.
But what do you know that x is?
Oh, so you just have to put it in. So it's just 4
x
squared minus 3, which equals to 4.
Right? You don't need to. It feels like you were trying to think about that, but realistically, you're like, all right, if I've got y equals something in terms of x's, but I now know what x's are, well, I can just sub that in and find y. Or other way around. If I know what y is, and I've got y in terms of x's, then I can sub in y equals to 4 and start solving for x's. Just keep that in mind. All right, cool. And then find the equation of the tangent. So y minus y1 equals m. What's your gradient? 5.
The gradient's 5.
Yeah, and then x minus
4.
Okay. Okay. And then let's finish this off. 5x. Take away 20. Take away 20 plus 4. There we go. Okay. That's double I. We're up to triple I. Find the coordinates of Q. That's weird. Find the coordinates of Q. Okay, what do you know about Q, firstly?
That the x value is 0.
Ah, too good. And then you already know that that tangent, the equation is right here. Y equals 5x take away 16.
Is the y value just negative 16?
Yeah, right. You're just going to sub in x equals 0. Ah, too easy. See what I mean by don't overthink it? Y equals negative 16. Therefore, Q is x is 0, y is negative 16. Done. Good job. The rest is just looks like it's basic differentiation. Oh, this big one. Radians. Well, that's not part of our course just yet, but let me see if we can do the rest. Now maybe the 2 points in parabola, the tangent of the parabola, P and Q intersect each other. No, done. All right, I'm happy with that. I'm going to